To calculate the pH of formic acid, we'll start with writing the equation for the ionization. HCOOH plus H2O. We use a reversible arrow because formic acid is a weak acid. The acid will donate its hydrogen. We will form the formate ion plus hydronium. Let's also write the expression for Ka because we're going to need that later on. So Ka is equal to the concentration of HCOO minus times the concentration of hydronium over the concentration of formic acid. Now we can set up our ice chart. So I is our initial concentration given in the problem as 0.17 molar. We don't have any ions initially. The reaction can only proceed in the forward direction, so our change is minus x plus x plus x. And to get our E, we just add I and C. So we end up with 0.17 minus x, x, and x. To solve for x, we can plug in our equilibrium concentrations into the Ka expression. Ka was given as 1.8 times 10 to the minus 4. Concentration of formate and concentration of hydronium are each x, and so x times x is x squared, and 0.17 minus x is the concentration of formic acid. Remember, since we are dealing with a weak acid here, we can assume that x is going to be much, much, much less than 0.17, which allows us to simplify this expression in the denominator and leave us with 1.8 times 10 to the minus 4 equals x squared over 0.17. This equation now becomes a lot easier to solve because we don't have to use the quadratic formula. We can multiply both sides by 0.17 and then take the square root, and we end up with x equals 5.53 times 10 to the minus 3. pH is equal to the negative log of H3O plus concentration. And we solved for x, which is the H3O plus concentration, so we can plug that into our pH equation. Solving, we end up with pH equal 2.2.